Okay, we're back again. We have this time out, okay, we're going to do all the things we did last time. Given an equation, we're going to come up with a mapping notation, and this time out, we actually have a graph that we're going to move. So what I have here, it's not a parabola. Okay, these mapping notations and these equations can apply to any type of graph whatsoever. This is, I don't know what the equation of this graph is at all. This is just a graph made up of several line segments. And what I've done here is we were given the equation, and we have to come up with a mapping notation whenever we want to sketch a new graph. So we're asked to sketch g of x, which is a transformation of the f of x graph. So let's do the mapping notation. That part isn't new. Okay, we can just make this x minus 4 because it's x plus 4 in the equation. And then we have y minus 3 because there's a minus 3 at the end. Okay, so we know we have a horizontal translation of 4 units to the left and a vertical translation of 3 units down. So we're taking this graph that we have in front of us and we're moving it 4 units left and 3 units down. You could probably do this without a table of values. Okay, you could probably just be able to see visually, okay, I move this 4 units to the left, 3 units down, I can make my new graph. But what I've done is this is a way that works every single time. A little bit later, when the mapping notations involve stretches and reflections, you're definitely going to want to go with this method. So let's start right now. Okay, what I've done on the left here is I've created a table of values for all 5 points on my graph. So I've labeled them A through E. And I'm going to, on the right, I'm going to create 5 new points for my new graph. And I can use the mapping notation and some very simple algebra to come up with these new points. So here's what I do. Okay, I start one at a time. I start taking my x values, so I can start with negative 4. And I can put that into the mapping notation for x. So I place that negative 4 in for x, and I work out minus 4, which gives me a minus 8. So my new A point is going to have an x value of negative 8. And then similarly, okay, I take my y value for my first point of A, which is a 3, and I put that in for y into my mapping notation, and I go 3 in for y, minus 3, which is a 0, and I've created my new point for A prime. Okay, my new corresponding point A on my new function g, which is a transformation of the function f. Then I can continue doing that for the rest of the 4 points that I have. I'll kind of breeze through this a little bit, okay? But if you do that simple algebra right there, you're going to get these numbers right here for x. And then if I take all the y values and put them into the y part of the mapping notation, I'm going to have these numbers right here. And then what I can do is I can take those 5 new points that I've created for g, and I can sketch those on my graph. So what I'm going to have here is I'm going to have negative 2, negative 1. This is my E prime. You can label them if there's room. We have negative 3, negative 1, negative 5, negative 2, negative 7, negative 2, and negative 8 and 0. Usually don't get these many emails. I get a lot of emails, usually not this much. But anyway, that's not your problem, that's my issue, so you don't have to deal with that. And away we go. Okay, we have just created a new function, g of x, which is definitely the same as the old original function, just in a new location. That graph has been moved 4 units to the left and 3 units down. What you guys can do is you can continue with numbers 4, b and d, or b through d, sorry, on page 13, similar to this question right here.